Do y'all have your meats?
Opposite.
Let's have a couple word problems.
I do takeout, but
I'm not gonna take out
Yes, I
that
have.
kind of thing. That's weak.
Problem.
That's weak.
I know, I'm just saying. Scotch
That's good information.
Okay, I will let you know now that your mom just started like arguing with me about how you don't want to go to prom the entire time that I was there with her yesterday.
Yeah, she texted me saying, please convince Scott though. I was
She
like,
didn't
I'll
even
try.
text me.
Why
What are your
that?
reasons? I mean,
that.
come on.
I mean, do what you want. Do what you want. What you want, father. Don't do that.
Okay.
I mean, sure, I don't care, but
Computer.
Jesse, you're going all over the place. Just
point is, I told your mom I'd try, but
All right, guys.
so just tell her that I really worked.
The rest of
Really
this assignments problem set is going to just try to review all the stuff we talked about with derivatives. Because there's kind of like there's like the how to take a derivative side of things, and there's like the what can you do with the derivative side of things. So this is going to be reviewing that using like the e to the x log of x, so on and so forth. So
funsies.
funsies indeed. Funsies indeed. So the first one is like, well, what's something you do with a tangent? Well, you can write a tangent line equation. So you can write, so if you have a curve, y equals e to the 3x, something like this, at the y-intercept, oh, great, there would be a tangent line there that just hits the graph one time. Okey-dokey? So to get the equation of a line, you need the slope of the line, and you need a point on the line. What's the point? 0.
1.6.
E to the 3 times 0 power is 1.
Okay, you really made me doubt myself. I was like, 1, and then you were like, and I was like, 1.
This is a math fact that,
Anything to the 0 power? Is it the 1?
yeah, not only to see, yeah, really anything to the 0 power is 1. So make sure you know that fact. Okay. By the way, while I mentioned that, it's also true that the natural log of 1 is 0. Those are basically the same exact fact if you think about them. It's like saying that 2 times 5 is 10, and also 10 divided by 2 is 5. It's kind of say the same thing.
Yeah, it's like e to the 1 equals what? It's 0.
Exactly. Sheesh.
Sheesh.
There
Yeah.
you go. Okay, so what's the slope here? The slope.
This is what Brown wanted me. Sheesh.
The slope of this line is going to be the
Oh my
derivative
God.
of the function
That's what I just remembered.
evaluated at where do you evaluate the derivative? The x value, 0. So you'd say the derivative of this is
Oh shoot. You are all over the place, hon.
yep. So you have this is an e to the u case. E to the u will become u prime e to the u. And then we simply plug in the value that we are wondering about. What do you get if you plug in 0?
3.
So the slope is 3. And so the equation of my line is very simple equation, actually. It's nice.
Okay.
Isn't that Nito burrito?
That is Nito burrito.
Nito burrito.
Can you leave that there for a second? Yay. Because I was eating my donut.
I got too busy writing that down, Mr. All. Can you just go through like just explaining like how you got from.
So the slope
From
is the
everything.
derivative, right? Yeah. Derivatives are slopes. So the first step was just to recognize that to get a slope, I have to take the derivative of my function. And not to take the derivative, but I take the derivative and evaluate it at the x value I care about. Because obviously this graph gets way slopier as you go. So you have to specify what x value do you want to take the derivative at. So you take the derivative, so this is, from here to here is basically just this idea, e to the u, take the derivative, you get u prime e to the u. So our u was this 3x, meaning u prime is 3.
Yeah, I got it now.
Then you plug in 0, you get 3. So, and then we came back and said, okay, that means with my y-intercept given as 1, then my equation is 3x.
Cheryl, thank you for the donuts. Appreciate it. It's very good. It's exactly what I needed.
Yeah.
Yeah. Appreciate it.
Um, I'll say 15 for you. It's making an argument, meaning just it's not a proof. It's not like you don't have to write a full proof, but this is kind of giving you a hint right here. You can, by drawing a tangent line, and you'll want to make some sort of claim about how, because of the concavity of an exponential function, the tangent line is going to be beneath it. And a drawing, of course, would support your argument quite a bit. And you're going to make this argument that e to the x is greater than x plus 1 for any x value you choose. So anyway, say that one for you. And same with 16, tangent line, and same with 17. They're all tangent lines. Well, so you're going to have a picture like this as sort of the cornerstone of your argument, which is showing how you can draw a certain tangent line to the curve. So if you draw e to the x and then pick a certain tangent line, hint, hint, you can show that the curve is always above that tangent line, and therefore e to the x is always greater than x plus always.
So we just have to draw that.
Not just that, you need to show,
Isn't x plus 1 the tangent line though?
Well, the tangent line is 0.
not of this one, but of.
Well, no, of that.
Yeah, so you're going to make an argument that if you draw the tangent line to e to the x at the y-intercept, you get this kind of shape. I mean, it's a different function, but the same kind of shape, and then you're going to you need to briefly mention the concavity of how, because this function's always concave up, the tangent line is going to lie below the curve, and so you can show that for any choice of x, the y value on the line, the x plus 1 line, is going to be less than or equal to the y value on the e to the x. Okay, so there's 3 tangent line questions there that I hope are pretty straightforward. That's all there is to them. Just identify a point, identify the slope. And you guys remember point slope form, hopefully. If you have suppose your point wasn't a nice y-intercept point, then you would just use point slope form, which is this. So suppose your point was off somewhere else.
Well,
This will be helpful when for the log function when you look at the x-intercept. Okay. Let's talk a little bit about increasing, decreasing, and concavity, and then we'll be done with the lecture portion of this, I guess. Let's look at 18. Let's do 18 together.
I know.
Find the global min of the function x times log. You can make some good thinky winkies on this question before you even do any calculus.
Really?
Yeah, because look at the function y equals x,
Whee!
and then look at the function log of x.
What? Just the sound effects. Really?
So if you think about what is this, what's going to happen to this function when, well, first of all, when you multiply these, what's the domain of the new function, the product? Yeah, x has to be greater than 0. So this is kind of irrelevant to start off with. But you have this interesting idea of like, for really small x values, this function is really huge, negative huge, right? And this function is really small. So it's not obvious. What's going to happen when you have really small values multiplied by really huge negative values?
Negative huge.
Could be. They're going to be negative, that's for sure, right? So if I picked some really small, let's say I picked a really small x value, I'd have a tiny little positive number multiplied by a huge negative number. But I don't know how tiny are we talking versus how big are we talking. So that's where it becomes unclear. So this is where the calculus is going to clarify things for us, okay? So I say, what happens when I multiply these functions? I want to look at the slopes. So what rule do I need to use?
Product.
The product rule. So A times B becomes A prime B plus B prime A. Should we list it out or can we just do it? We can just do it.
Let's do it.
Okay, this is going to be the A. This is going to be the B in this product rule. So A prime
1.
times B plus B prime times A. Cool beans?
Yeah.
So you get, that's weird,
I can.
because we know what that looks like. It would just be the same as this graph, but shifted up 1. So you could graph the derivative function at least. And what that tells you is that if x is really small, what kind of slope do you have? You'll have a negative. If x was 0.001 and you plug that in here, you'd have a huge negative number plus 1, which is still going to be a pretty huge negative number. So that tells you that it's negative slope values. Cool beans? Well, okay, so let's draw the f prime number line. This is where we're still not entirely maybe clear on what's going on here. So first of all, that's a mistake. Right?
Oh, yeah.
We just said that the domain of our function is from 0 to infinity. So 0 is a relevant number. Okay, this is for $1 million jillion. What number goes there?
1. No, it's
X.
Fine, X.
It's not 1.
It's equal to 1/2 of infinity.
What?
That is the worst answer.
No, it's whatever makes.
Just kidding.
It's whatever. That is the worst answer. It's whatever makes natural log of X.
are wrong answers.
So let's say we don't know. Well, we hopefully remember the idea, which is I want to know when is this going to equal 0?
Yeah.
Or be undefined, right? We've already covered that. If you plug 0 is the only number that makes this undefined, or any negative number. So the question we want to ask is it possible for this to equal 0? Mathy time. Subtract negative. Subtract 1 from both sides. Then we rearrange this. We say,
E to the negative 1 equals X.
is there a nicer way to write that number?
E
Arguable.
equals X.
You see?
It's just whatever E.
So
Yeah,
the
okay.
critical number on this question is the reciprocal of E,
Lit. Schwab.
which is a number somewhere between 1/2 and 1/3. Somewhere in that ballpark, since E is like 2.7-ish. You okay, Lillian? What's up?
Okay.
Question?
No.
Any questions?
No.
Is everyone okay going from here to here?
Yes.
Okay. And then so what I said as a sort of a precursor to this was because I know how the log function behaves, I know that if x is some really small positive number, this will be a big negative number that outpowers him. So I'm going to have negative slopes. And what happens if x is bigger than 1/e? Let's say x was 50. Well, log of 50 plus 1 is positive. Okay. So that tells me that my graph goes, this tells me my graph is decreasing, and this tells me my graph is increasing. Right? Decreasing, increasing. And we know the graph's continuous. So, this. By the way, that tells me, that actually answers our original question, which is, that tells me the graph is going to go, now I'm not really sure, is it going to dip? Will it go negative? Let's see. Will it? So it looks something like that. This is what the graph of x. Although I'm not sure, does it actually go negative or not? Let's think about that. How would I find the actual minimum value of the function? I know what the x value is.
Plug in 1 over e.
The x value is 1 over e. I need to plug this x value into
That one.
the actual function to get the y value. Okay, so let's do that. So f of an eth
No, I know. Hey, x and line of x are my OTP.
would be 1 over e times the natural log of 1 over e. And then this here is -1. Negative 1 eth.
I've heard a lot. Yay, -1 e.
Isn't that lovely?
That is beautiful. I love
Make
it.
us happy.
Wait, why is it going up? Because I thought x.
So we know that the graph you can't plug in 0. And we know that it's decreasing
6e.
from 0 to this number. So what's the only way that the function can be decreasing, right? Like from 0 to that number, it's gotta be coming off an asymptote, right? And then this tells me when my function changes from decreasing to increasing and it's continuous, so that tells me that there's gotta be a local min there. In this case, it's gotta be a global min because of the fact that it goes down up. So, isn't that nice?
Beautiful. I love it.
Lovely.
Lovely. Now I'm gonna go. Yay.
What? Close to what?
1 over e. We were all really close to that.
Like the shape of it?
Although that other side, it goes to 0 and stops.
Oh, right here? Is it just an open dot?
That's what I was trying to. It doesn't continue up anywhere else.
Ooh, fancy. Oh, is that because earlier we said that it has to be negative numbers, right?
Yeah.
Oh, just testing you, obviously, right, Aiden? No, just kidding. No, I forgot that. I forgot that earlier we said that if x is, for small x values, if it's a positive times a negative, it can't be positive. So it actually has to look like this.
Actually decent.
Does that make sense? Yeah. Oh, okay, I gotcha. So that actually answers a really challenging question, which is what's the limit of this function as x approaches 0? The answer evidently has to be, although I guess does it necessarily have to hit 0? I mean, I guess that doesn't prove that. It could, the open dot could be lower. It could possibly be lower, right?
Well, plug in.
Close enough.
Can't
to
you just
go
plug
for it.
in 0?
No.
Oh no, you can't do that. Okay, but if you could.
That's what a limit is. The limit is if you could get really, really
well, I know,
close.
that's what I'm saying. Is it 0 though? Do
I
we
think
know?
Aiden, you graphed it and you said that it pretty much comes up and approaches 0.
Yeah, it's undefined at 0.
Okay. Well, I'll show. Yeah, we know it's undefined at 0. Well, we'll cover a technique later in this class called L'Hopital's rule, which is a method for calculating limits. And this is, I think, one you could do with L'Hopital's rule, and then you could prove
How do you
that the
spell
answer
L'Hopital?
is, huh?
How do you spell that?
L'Hopitals.
So it's like French.
Maybe.
Sounds like the hospital.
We don't like French things though. We'll call it Freedom's rule.
Wait. Isn't hôpital hospital in French?
Maybe.
Because hospital is hospital in Spanish, but I think it's hôpital. Okay. I'm looking it up. I'm looking it up.
Okay, so
Nobody cares.
also, guys,
about
do
me.
you,
That's okay, I care.
if you're feeling confused by the talk about this region, do you understand that to answer a question like this, you don't have to necessarily know those details about what's happening. I think it's interesting to look at that, but to find the global min, you just have to be able to take a derivative, analyze the number line, right? And then plug your critical number back into your function. Does everyone, we all understand that?
I was just confused.
Oh
Because
my
at the beginning,
gosh.
I thought we were just taking derivative of the natural log of x, so I was confused, but then I realized.
I
Oh,
told
you
you,
didn't see the X.
L'Hôpital is the hospital. L'Hôpital is literally the hospital in French. I know what I'm talking about sometimes.
I think in this case it was named after some dude, but this might be another example of the Stigler's law where
Yeah, thanks, George.
I don't think L'Hôpital came up with L'Hôpital's rule, but maybe he did. I can't remember.
Oh, man.
I think it was just a cool.
But I was just like, wow, I think that's hospitals. It is.
Okay.
Why do I know that?
Let's do one more together. Do we have time?
We have 3 minutes.
Well, how about this? Right?
Yeah, there you go.
So for 19, same question. I want to know where's the local extrema for a function like this. So the procedure is pretty straightforward. This one's a bit more complicated of a function.
Yeah.
We got to use two rules here. The product rule, because I got a function
And the chain rule.
times a function, but then that's going to involve a chain rule. So
Winkies.
your derivative, okay, so you ready? It's going to be, let's call this A and this B. So A prime times B, that was easy. The next part's not so easy. Plus, okay, so B prime, that's a whole other thing in it. Like, to get the derivative of this, you have to think of it
U squared.
as a u squared turning into a 2u prime. Is everyone fine with that?
Yeah.
So this would be 2 times u times u prime.
Yep.
So that's me doing the chain rule inside the product rule, right? And then don't forget a prime b plus b prime a. Don't forget that guy. So
Is that x supposed to be squared or not? 2 natural log x. Is that squared?
nope. So this is so u squared turning into 2u
Okay.
u prime. So there's my 2u u prime. So so those cancel. Now, can we set that equal to 0?
Probably.
Yeah, we can try. I've got thing squared plus 2 times thing.
Sounds like a Dr. Seuss poem.
Oh, he's canceled now.
I
So what you
know,
The F word,
Which one?
factor. I'm going to factor out a log of x from that, right?
Yeah.
Feels me?
Yeah, we do feels you.
And now, if this whole thing is going to equal 0, if this product is going to equal 0, either the log of x has to equal 0, or he has to equal what? Is that a yeah? Is that a bruh and a yeah?
A bruh and a yeah.
It can. The log of 1 is 0. You're thinking you can't take the log of 0, but the log of x, the log of 1 is 0. And then how about this guy? E to the negative 2, which is AKA 1 over e squared. Who's more biglierist, him or him? Who's the bigger number? He's bigger. So my number line, my y prime number line, 0 is the, got to cap it off, right? And then you got 1 over e squared. Yeah, big mood, no cap. Am I right, guys?
Yeah.
Sheesh.
Combines so much there.
And you're going to have to go and thinky winky about, are these intervals positive slopes or negative slopes? And then you got to figure out the rest, okay? Cheese!